everyone, it's Kirk with Lowry at Home. It is a bit of a rainy day outside, so I'm inside right now. And you know, a day like today is great for curling up with a book or sort of thinking about some big picture things, so I've got something special for you. This week is Astronomy Week because on Saturday is Astronomy Day, so I thought we should talk a little bit about astronomy this week. And so today is a great day to do that. I got a little bit longer piece for you. This is about 14 minutes long. And it takes a little time to explain the size of the universe, which is what we're talking about. We're going to try to comprehend the size of the universe. Today's guest is me, so let's get right to it. It is Astronomy Week, and so I thought it'd be kind of fun to think about how big space is. It's fun to look out there at the night sky, but when we do that, we're looking at space. How big is space and the things in there? I like to say space is huge. No. Not however big you're thinking in your head right now, it is bigger than that. It is really, really big. Now we, as humans, we are explorers. And ever since, we came about, we started looking around and exploring and trying to see our world. Early on in our history, all we could really see was out to the horizon of wherever we lived. Here in Minnesota, the kind of terrain we have, when you look out at the horizon, you're maybe seeing 3 miles away, not very far. But if you can climb up just 100 feet high, maybe on a hill like this guy, you can now see 12 miles away. So we very quickly learned that the higher we got, the more perspective we gained on how big the world is. The higher up you get, the more perspective you gain. So let's go even higher. Let's go up into space. Now we can see that we live on an enormous planet, and it is absolutely enormous. If you spent your entire life exploring this planet, even with all the technology we have of airplanes and ships and these things to move you around and cars, you could spend your whole life exploring and you would never, ever see even just the land part of our planet, let alone all the oceans. You can never visit it all. You can never explore it all. That's how big it is. So our world is enormous. But we have another world orbiting our planet. Just right there we have the moon. And the moon is a whole other place that we've only explored a teeny tiny bit of. And in this vast universe, the moon is super, super close by to us compared to everything else. But how close is it really? Let me show you a size comparison here. So over on the left-hand side of the screen here, all the way to the left, we have the Earth, and then we have the planets lined up. We have Mercury, Venus, Mars, giant Jupiter, Saturn, Uranus, and Neptune. And you might be tempted to think that over on the far right, that is Pluto. But that's not Pluto. That's actually the Earth's moon. That's how big the moon is compared to all these things. But why is it way over there on the end? Because this is actually to scale, to show you that if you took all these planets, including Jupiter, that is so large, you could fit 1,300 Earths inside it. As big as they are, space is even larger. The empty space of space is larger. All these planets lined up would fit between the Earth and the moon with about 5,000 miles to spare. It is 238,555 on average miles between the Earth and the moon. It's a huge, huge difference. And it's the closest thing to us, and yet it is so far away. Now let's look at something even bigger that makes this look tiny. And that's the sun. The sun is even bigger. If the sun were hollow, 1,000,000 Earths could fit inside it. Remember, we had about 100 or so of the Earths inside Jupiter. You can get 1,000,000 Earths inside the sun. We would not do too well. We'd be burned up at that point. But if it was a hollow ball, we could fit that many inside there. Now, we can feel the heat from the sun on our faces today. If you go outside and face the sun, oh my gosh, what a nice, beautiful day. You could feel that heat. But keep in mind that the sun is very far away. It looks so tiny in our sky because it is so far away. The sun is 93 million miles away. Now that is a distance that if you had 11,760 Earths lined up in a row, that would be 93 million miles. These numbers are getting so big, they're kind of ridiculous. They're hard to understand. So let me talk about some other big numbers to confuse you here. Not to confuse you, to help try to illustrate how big, far away things are. Let's talk about the light coming off that sun. Light goes very fast. Light is the fastest thing in the whole universe. It can travel 670 million miles per hour. If I snap my fingers like that, in that one snap, light could go around the Earth 8 times. And even traveling at that speed, what you call the speed of light, 670 million miles per hour, it still takes light 8 minutes to travel from the sun to the Earth. That's how far away we are from the sun. Even traveling at that enormous, mind-boggling speed, it still takes 8 minutes to get here. Now, our sun is not particularly special because it's just a star. And when we look out at the sky, the night sky is filled with stars. There are more stars than you can count looking at the night sky. This picture was taken, obviously, with a camera, and cameras are more sensitive than the human eye, so we see more of those stars that are out there than our eyes do. And it's really just sort of mind-boggling to see how many of them are there. Now, you might see a sort of a glow of more stars through the middle. We call that the Milky Way up in the sky. The reason that's called the Milky Way is that we live in a galaxy, which is a group of stars, and it's called the Milky Way. We can't see what it looks like shape-wise because we are inside it. We believe it to be a spiral galaxy that's kind of flattened out like a pancake or a ball someone has stepped on. And so we don't see as many stars on the left and the right of this photo because we're looking out the top and the bottom of the galaxy. But in the middle, we're looking through one of those spiral arms. I believe this is actually a photo looking toward the core of our galaxy, perhaps. So we can see a lot of stars that are packed in there. Our galaxy, the Milky Way galaxy, is absolutely enormous. It's a monster. It has somewhere between 1,000 million or 4,000 million stars in it. We haven't been able to count them all. There's so many and they're blocking our view of each other. This thing is huge, okay? Our galaxy is big. Now remember that speed of light, that 670 million miles per hour? It took 8 minutes for the light to get from the sun to the Earth. What if you wanted to send that beam of light from one end of our galaxy to the other? Well, we have a special name for this. We measure big structures like this in something called a light year. That is the distance that a beam of light or a particle of light could go in 1 year's time. So traveling at that 670 million miles per hour. If you're going that far and you give yourself a year, that's 1 light year of distance. And you can imagine that must be just what we call an astronomical distance, a hard to understand distance because you're going so fast for so long. But here's the big news. Even going at the speed of light, it would take 100,000 years to go from one side of our galaxy to the other. That's how big it is. It is 100,000 light years across. That thing is enormous. Now we can't see what our galaxy looks like, but what if we take a peek at one of our neighbors? Our neighboring galaxy is the Andromeda Galaxy. Let's talk about that. So the Andromeda Galaxy is something we can see up in our night sky, and we're going to zoom in on it here. This is a video that someone made on YouTube, and I got special permission to show it to you guys. We're going to look at just this section of the Andromeda Galaxy. This footage is from the Hubble Space Telescope. And when you look at the Andromeda Galaxy, which is our nearest neighbor, you can see it looks like a big, sort of hazy patch of gas out there in space. But this is a very high resolution photo, so we're going to zoom in closer. And what I want you to see, when we get all the way zoomed in here, is that these are not big clouds of gas. These are individual stars that make up this image. Every little tiny dot on this picture is another star in the Andromeda Galaxy. And what we're going to do here in just a moment is start scanning across the galaxy. Try to keep count how many stars you see. Of course you can't, there's so many. I mean, they fill the entire frame here. But look how packed together these stars are. And we're going to slide across the galaxy. There are big stars, there's small stars, red stars, blue stars, yellow stars. Every kind of star you could imagine in our neighbor galaxy. And as we get closer and closer and closer to the denser core of the galaxy, you see more and more and more stars. It's just stunning to see how many there are. And this is, again, the closest galaxy to us, other than the Milky Way, but it's 2.5 million light years away. So this light that made up the picture took 2.5 million years to travel across space and come to the camera, to the Hubble Space Telescope. Now we're getting into the deep core here of the galaxy, and as you can see, it's just too many to count. There's like one star per pixel in this image. It's basically solid stars. Now, if you were toward the middle of this galaxy, it would not seem like, there's not a star just right next to you. There's still vast empty spaces in between all these stars, even though they look so close together from this far away. And we're going to spiral around here and start to zoom back out away from the inner core right here of the Andromeda Galaxy. And even with this many stars, look how many are there. Even with this many, when we pull back out, one of the things I want you to appreciate is that this is not the whole Andromeda Galaxy. We just took a little tour of a little piece of the galaxy. We'll see here exactly how much we just saw. It's that much of this much of a galaxy. So the number of stars is staggering, but if we zoom out, that galaxy only takes up this much of our night sky. Now to wrap up, wait, why does it say this? Our galaxy is tiny? Hold on, I just spent a lot of time telling you galaxies are big, and now I'm saying a galaxy is tiny? It's all a matter of scale. Let me show you something here. This is the Hubble Space Telescope. It's about the size of a school bus. It's one of our most powerful telescopes that we have. And astronomers asked permission to do something kind of strange a while back. They said, we'd like to take a picture of nothing. Now, this is one of the most expensive telescopes in the world. And so if you request to take a picture with it, you better have something pretty impressive you want to get a picture of, because there's lots of people competing with you. And these astronomers said, we would like to essentially take a picture of a spot in the night sky where there is nothing. That's what we want to take a picture of. And people thought they were maybe kind of nuts. And they said, well, how long do you just want to snap like a snapshot? And they said, no. We want to take a picture of a spot in the sky that is the size of a head of a pin outstretched at an arm length. So you can imagine what a tiny spot in the sky that is. And we want to leave the shutter essentially open for 100 hours. We want to take a 100-hour exposure of that spot where there is apparently nothing in the sky. So we want to gather up as much light as we can and see maybe there is something there. You guys ready to see what they saw in that 100-hour exposure? Here we go. That one empty pinpoint in the sky contained over 10,000 galaxies. So when you look up at the sky, this is called the Hubble Deep Field, by the way. When you look up at the sky and you see a spot and it looks like there's nothing, every single spot in our night sky essentially has this many galaxies in it. Those are not stars, mind you. If you look carefully, all those points of light, except for maybe the bright one down in the lower right-hand corner that has the little streaks around it, the little light lines around it, everything else here is a galaxy. And each of them probably have trillions of stars in them. We now believe that our galaxy, based on photos like this, probably has somewhere over 200 million galaxies and possibly more. So when you stop and think about the amount of space in space, it's truly mind-boggling, and it's hard to really even comprehend
how much space is out there. But this is astronomy week, astronomy day on Saturday. You obviously don't have a space telescope in your backyard to take a picture like this, but I hope you'll go out and take some time and look at the stars we can see and really appreciate just how huge and magnificent our galaxy and our universe truly are.
Thank you so much for sticking with us for that whole segment. Hope you enjoyed it while we thought about the size of the universe. If you have any questions about astronomy for Astronomy Day coming up on Saturday, go ahead and leave the questions down in the comments, and I'll try to answer those on Friday. As always, any questions you have about any natural history topics, put those in the comments and we will answer those. Thanks for being part of the Lowry family. For here at Lowry at Home, I'm your host, Naturalist Kirk, saying thanks and have a great day, everyone.